So what we want to do in this video is we want to look at the case of free fall. So to look at free fall though, what we're going to do is we want to first start by looking, let's assume we have some block or we have some ball sitting on the ground. Now when we have our object sitting on the ground, and I know I didn't draw it flush to the ground, but if our object is sitting on the ground, and when we look at this, when we're sitting on the ground and our object is just sitting here doing nothing, we know that it's in equilibrium. And so when we're looking at this and we look at equilibrium, we know that there's two forces acting on our object. One is the force of gravity down, Fg. It acts on either object. The other is the normal force that we said, or the support force as it's called. Force N or force S, however you want to view it. So, what happens is when we look at A, when we use Newton's second law and we say A is the sum of the forces over the mass, when we look at the sum of the forces here on either case, we have Fn minus Fg over m. But Fn minus Fg, that's 0 over m. And so the idea is that this, because A equals 0, the object is in equilibrium and there's no motion. Now, let's now take our same objects that were just in equilibrium, and let's say now you're standing on a cliff and you take either your block or your ball and you drop them, you let them go. Well, now what happens? Let's look at the sum of the forces. So now when you look down here, A is the sum of the forces over m, and this is going to be, there's only one force now, Fg. So you get your force of gravity divided by m. Now, what is Fg? Well, Fg is essentially going to be the mass times the gravity of the object, g, which is essentially the weight. It's the force that gravity pulls down on an object with. So when we're looking at our acceleration, what's the acceleration of the object? Well, it's mg over m. And it turns out when you let something go and it falls down, the acceleration of the object is g. And this is called free fall. Whenever the acceleration of your object equals gravity, then you're experiencing free fall. Now the interesting thing about free fall is what happens if your mass goes up. So let's say that the cube has a mass of 1. Let's say the cube has a mass of 1, m equals 1 for the cube, and let's say m equals 2 for the ball. Well, so what happens is, let's look at the cube first. So we have 1 times g is the weight, and then we put 1 in here, and then we put a 1 down here, and you get 1 times g divided by 1 is g. Well, what happens when this goes to 2? Well, let's say you put 2 in now. So you put a 2 in. You get the force of gravity is 2 times g. Well, that becomes 2 times g over 2, and acceleration is still g. And this is why a while ago that when we were talking about Galileo and we said everything falls at the same rate. Well, this is why, because essentially if you don't have air friction, we said that in a vacuum everything would fall at the same rate. And that's what we see right here, that it doesn't matter the size, the mass of the object, because as the object gets more massive, gravity, the force of gravity gets stronger, but it does so to keep pulling, so the acceleration is always g. Now, we'll also take another look, not in this video, but in a different video. We'll take a look at we'll look at some ideas of air friction and how air friction changes this. But in general, the idea of free fall is the condition when your acceleration is g. So when your acceleration is 10 meters per second squared, you're in free fall.